the past, actually, I only review the problem that some students are wrong, but this time so many wrong, so for a few students, so we will go over every problem. Okay, we'll go over every problem. Richard, how are you? Okay, let's get started. Okay, let's get started. So let's see the first problem. Okay, I'm going to go over every problem. One moment. Okay. Okay, let's work on the first problem. Okay, the first problem we have, consider the following: my value multiplier, and then my value times multiplier plus my value divided by multiplier. Okay, and then get answer times multiplier. So this one actually is a kind of the using the variable. Okay, so you have my value. So my value, I use a v, initially 17. Multiplier, I get 3. Okay, so answer, then there is an answer. Okay, so answer will be equals my value. My value is actually 17. Take modular by multiplier, that's 3, plus my value. Okay, that's 17. Okay, divided by multiplier. Okay, divided by multiplier, this one will be equals 3. Okay, so here this one should be 5 plus this one modular should be 2. So the answer now becomes 7. Okay, 7, and then what? Answer times multiplier. Okay, answer times multiplier. Multiplier is 3, so 7 times 3. And then we get 21. 21, answer is E. So first problem is actually E. Okay. First problem is E. So I'm going to go over every problem, okay, because some of you get many wrong, so I cannot just skip problem. Okay. So let me continue for the second problem. Okay, second problem we have this Boolean condition. Look like it is a kind of the logic simplification problem. Okay, so let's actually try to do it this way. Okay, so the first portion here, this portion we have A less than B or B less than equals C. Okay, this one bar, you get A greater than B and B actually, okay, this one greater equals to B. Okay, greater equal to B. Here is actually bar should be greater equal. This one is greater than C. Okay, and the second part also have this one A less than C or B greater equals A. So you will get A greater equals C and B less than A. Okay, let's summarize it. So we get A greater equals B and B greater equals C, greater than C, A greater equals C, and B less than A. Okay, B less than A and get A greater than B. So actually these two conditions we can cancel out. Okay, so it just has A greater than B. And then B greater than C. Okay, A greater than C. So the relationship is only A greater than B greater than C relation. Okay, so that's the final condition we have. It actually only has A greater than B greater than C condition. So which one, under what condition the Boolean value will be evaluated to true? And the answer is 3, 2, 1, B. Okay, so the problem 2 is like that. Okay, the key thing is that you have two ways to solve it. One is a simplification of the equation like me, or you plug in the data. Okay, but plugging the data, you may need to be careful. There's another one, say, all condition will be true. So you have to make sure that you don't, you still require the logic simplification, okay? You still require that. Any questions so far?
No.
No. Okay, number three, we have my array and then index and do this thing, and then what will be the value stored in my array executing the call. Okay, so basically this one actually is doing operation. Okay, so it is trying to find a value that actually is less than 7, then you will get out of the loop. Every time the index value plus equals 3. So let's try this one. We do have, let's go over these. Okay, so we have index 0, 1, 2, 3, 4. Okay, 2, 3, 4, 1, 7, 6, 8. Okay, so 5, 6. So this array is like this. Okay, this array is like this, and it actually is starting from index equal 0. Try to do traverse. Okay, try to do traverse. So this one increased by 3, it will become increased by 3, you become 5. This one increased by 3, it will become 6. This one increased by 3, it will become 7. But index increase before you compare, so actually you go over. This one increased by 3, it becomes 4. This one stop, so this one don't go over anymore. So you got 5, 6, 7, 4, 7, 6, 8. This one you got D, number 3 is D is the solution. Okay, this one's using this table scoreboarding. Okay, scoreboarding. Number four, we have 1, 2, 3 problem. Okay, we have 1, 2, 3 problem. So this one you need to go through it to see what 1, 2, 3 is, and then pick a solution, because we only have roughly 2 minutes to work on a problem. So roughly go over the problem. Okay, so here we have a class purchase item that has 3 instance methods. Okay, get price, get item, get months, but they are no data field. The company is billed. A company bill at the end of the quarter. Until then, use a radius of online purchase item object to chase. So there's a radius of these. Okay, and this one is online. Okay, of these. Okay, they are instant available and something not shown. So you have these 3 items that you can use. Okay, so you have these online things, and you want to see that the company decided to offer 20% off the promotion or item purchase on September. So you want to get months equals September, then all of the price should be decreased by 20%. Okay, so which of the following segment probably calculate the correct total price at the end, and the total price is the whole thing. That item, get the item. Okay, get the item, and then get the price. Okay, item and price. Okay, so let's do this one. Okay, so here we have this one is online purchase item. So basically, it's called items. So you go through every items. The items get I that get months that equals September. So okay, these are September, and then total plus get item, get I that get price plus times 8.8. Okay, that's actually okay. If there is no discounts, then we actually will we will increase by so number the 1 actually is true. Okay, the 1 actually is true. So we just pick that, and then 2. Let's go into 2. 2 we have a total and online purchase. So purchase is element. A purchase get I. So purchase get I is wrong. Is for each loop. There's no need to get I. So this one is wrong. So 2 is wrong. So we have 1 correct. 2 is wrong. Now we continue. Okay, then we continue. Third one, we have this one. This one is wrong. Okay, the I get started with item dot size. If you want to do backward traversal, you need to get from item dot size -1. So this one is also wrong. So this number 4. The answer is A. A, okay, 1 only, okay. The answer is A, 1 only, number 4. Number 5, okay, number 5. Number 5, consider the following for a mystery number n, okay, if n less than equals 1, actually return 1, 2 plus mystery n minus 1. So we have mystery of 5. So let's write down mystery of 5. You will call this function, and this function will become 2 plus mystery of 4. And it will become 2 plus mystery of 3. It will become 2 plus mystery of 2. Okay, next one, it will be 2 plus mystery of 1. And mystery of 1 would return 1. So this one would be 3. Mystery of 2 will return 3. Mystery of 3 will return 5. Mystery of 4 will return 7. Mystery of 7 will, even though 5 would return 9. Okay. So basically number 5 is D. Okay. Number 5 is D. Okay. By drawing this recursive calling diagram, you should be able to solve it. Okay. Okay, number 6, consider the following things and then what it would be in the mind stream after execution. So let's look at how it works. Okay, so here we have H. Okay, it's mind stream. Index equals 0, index less than 4. So here for I equals 0, I less than index. So basically, each rung of this you will be wrapping your answer by the index number of the A on each side. So initially you have only one H. Okay, you have only one H, and then your index starting from 0, 1, 2, 3, 4 will not get in. Okay, 4 will not get in. So you have 0, 1, 2, 3. Okay. So when your index equals 0, you're not going to wrap it. Okay, you're not going to wrap it. And index equals 1, so index 0, you're not going to wrap it. It will just be H. Okay. Index equal 1, you are going to wrap AA on the side. Index equal 2, you're going to wrap another layer of the AA, 2A on each side. Okay. Index equals 3, we are going to have so on each side you should have 6A. That should be the answer. So number 6, you got E. Okay, you got E, this one, number 6. Okay. Number 7, you have consider and find code. You have random number. So this one is 0 to 50. So far here is 0 to 50 up to here. 49. Okay, 49, not including 50. Plus 10. So 0 to 50, not including 50. And plus 10, you should get 10 to 60, but not including 60. Okay, so it actually is from 10 to 59 inclusive. So number 7 is B. Okay. The way we solve it is using this notation. Okay, we teach you many, many times. Any questions so far?
No.
Richard, are you okay? Hi,
Yeah.
Richard, are you okay? If any question, you must more voice out, okay? I can't be interrupted, okay? Edison, are you okay?
Yeah, I think I'm okay.
Any questions so far? No?
I think the first you are okay.
Yeah, any question, if you still have question and something you're wrong, you are okay to interrupt me at any time, okay? So number 8, we have this thing. This thing is actually print. So print, the first one is 13 plus 6. Remember, it is what? The dual. Integer plus integer become integer. So it is 19 plus APCSA, it becomes 19 APCSA string type plus 9 minus 5. 9 minus 5, you get 4. So you absorb 4 into it. So APCSA and then 4 and then 4. So that is the final answer. Wait, no. The 19, okay, 19. So it should be C. Okay. Number 8 is C. Okay. Is that okay? But remember where you should do integer summation, where you should do the string concatenation. From the left, is still integer plus integer. So this one is integer, you get 19, okay? And plus the string, you become 19 APCSA, okay? Plus 4, you get a 4. Plus 4, you get another 4, okay? So that's a concatenation after the APCSA, okay? Before that should be number operation. Number 9, okay, you have num1, num2. If num1 take modular by num2 equals 0, then you divide it by half. You return the half of it, okay? If n1 is a multiple of n2, you divide the two numbers by half, okay? Otherwise, you guess the number num2, and then num2 and the num1 more num2, okay? And then plus num1 modular by num2. Okay, this one is a little bit strange, but we need to follow the rule every time. Okay, so let's get started. This one's guessing. So initially we got guessing 3 and 17. Okay, 3 and 17. So first one, the rule is that num1 10 modular by num2, 3 10 modular by 17, not equal 0. Not equal 0, so we go to here. We guess num2 17, and num1 10 modular by num2 is 3 10 modular by 17 is 3, plus num1 10 modular by num2 actually is 3. Okay, that's the first one. So this one we actually swap 3 and 17 and also get another 3 there. Continue to call this one. Num1 is multiple of num2. No, it's not. So we actually guessing what? Guessing actually num2 is 3 and num1 10 modular by num3 actually it become 1. Okay, I'm sorry, it become 2. Actually 17 10 modular by 3 is 2, okay, plus 2. Okay, so this one is this one. Now we have a guessing 3 and 2. Guessing 3 and 2, we actually should get, is a multiple of 3 is multiple of 2? No, so we continue to guess. We should guess 2, and num1 get num2 is actually 1, okay, and then plus 1, okay. And guessing of 2 and 1 is a multiple of it. Yes, it's a multiple of it, and it should be num1 plus num2. 2 integers sum together is 3. 3 divided by 2, so this one actually get 1. Because it's 3 divided by 2, it actually get 1. It's integer division. So this one return a 1. So 1 plus 1, this one return 2. 2 plus 2 will return 4. 4 plus 3, you return 7. So eventually number 9 is B, getting a 7. Okay, using this function calling function way. Okay. Number 10 is automobile class. Consider the following segment that appear in another class. So many code. Okay. What is printed after executing the code? Okay, this one you have to trace it one by one. So I create a car called my car. It's a Ford and Fusion. Okay. So there's an object called my car. So my car pointing to a car, so Ford and Fusion, okay, Ford and Fusion time. Then next one, we actually create an automobile company car created that actually is Toyota and Corolla, okay, and then company car, my car's object assigning to my car, so company car, so company car pointing to this, cut the original company car's pointer. Okay, so it becomes something like this. Okay, and then And then after that, my car create Kia Spectral. So here we create another car that's actually called Kia Spectral, and then you point it to here, you cut this one. Okay, then print now company cars Mac. Company cars Mac, which should be folder. Okay, so folder plus my car's model. My car's model right now becomes spectral. So folder and spectral. Folder and spectral is actually answer number 10. Actually, is A folder and spectral. Okay, the answer is folder and spectral here. Okay, A. So far it's still a class object problem on number 10, okay? Number 11, okay, so because we have too many problems, okay, I need to go over the 40 problems. So I don't want to ask you, okay, so because there are so many problems, we need to finish them, okay? Number 11 to 14, refer to the following class definition, okay? Here we have the table, the whole thing here, okay? Don't read it, you waste your time. So table class has 3 constructors, which of the following is correct from this practice. So there are three constructors of different parameter type. So this one is called overloading. So this one with the 3 constructors of the same type. Number 11, this one is called overloading. Okay, we talked about this before. This one is simple pick. Okay. Number 12, consider the following code segment. Okay, we have dot depot station equal new depot, Oakland and California. Okay, so new depot. So here remember the depot is two, so it's a state and city, but it is a mess up. Okay, the object created mess up. So state is actually Oakland, city is California. So we need to print the object of depot. So we need to look at the toString function. So toString function is ct plus comma, ct comma state, country, and active. So country and active, country is actually USA, active is true. So basically without other thing, you get this one, it will be California, comma, Oakland, USA, and then 2. So California, Oakland, actually USA and 2. So number 12 actually is A. Okay, it's A. The only thing that you need to be careful is the city and state got messed up. Okay, number 12 is A so far. Okay, number 13, we go to number 13. Okay, so number 13, consider the following class definition. Okay, this is a class definition, and then we are trying to find which of the following will compile without an error. Okay, so this one here we have a whistle stop extend depot. So depot is here. We have depot and we have whistle. So this one is an inheritance problem. Okay, so here public whistle stop. So whistle stop is a constructor that is a super no argument. Let's look at super no argument. Is there a no argument constructor? No argument constructor. So basically, one is wrong. It will compile with error. So one actually with error, one is wrong. Second one, we have whistle blow and then string true. Okay, do we have string Boolean type or available? So string. So my state, my city, my state, my country, Boolean. So yes. Number 2, no problem because we have string Boolean type. Next one, we have whistle stop. Okay, whistle stop city and province. Okay, city and province, and the variable names is province or city. It doesn't matter. Okay, so you super toString function. So super toString function. Yes, there's a depot super toString function. The order is wrong, but nobody cares. Okay, nobody cares. So this one actually, 1 is wrong, 2 and 3 are true. So number 13 is D. Okay, number 13 is D. Number 13 is D. Okay. 2 and 3. 1 is wrong because we don't have the no argument constructor. 2, 3, just checking the string type. There's no need to check about a semantic issue. Whether it makes sense or make no sense, we don't care. Okay, we don't care. Now here we have assume not correct, no argument constructor have been added. Okay, now no argument constructor have been added. So which of the following segment compile without error? So already it's a depot station equals already it's new depots. Okay, that's okay. You add the whistle stop. Yes, that's okay. You add a depot or a string false. Yes, that okay. So I think 14.1 is actually okay. 14.2 actually you use already so whistle stop equals this. No, you cannot put the depot object to the reference of the whistle stop pipe. So 2 is wrong. Okay. 3, I think is 3 here, center is okay. New whistle list, that's okay. Here you add a depot object to whistle stop reference. So it's still wrong. Okay, it's still wrong. So number 14 is 1 only. Okay, A1 only. So number 14 is A1 only. Okay, A1 only. Okay, number 15, consider the following code segment. String crazy, and crazy list equal the new array list of string. So crazy add weird and enigma. Okay, so crazy list has the weird and enigma. Okay, 2 things over there. And then we have for each string S crazy list, so weird and enigma would be there, and crazy sin 1 3. Crazy sin 1 3. Let's actually look at crazy sin. Crazy sin is CRAGY 0 1 2 3 4. So 0 to 3, 1 to 3 actually is RA. Okay, crazy string is like this. Okay, so crazy string plus 0 and 4. 0 and 4 actually is 0 1 2 3. So that actually is CRAG. Okay. Oh, okay, I'm sorry. Actually, this one is not. This one is the S, okay? It's the AS. You need to add to the crazy sin, I'm sorry. So this portion a little bit wrong, okay? So the first one, the first object you get is actually, weird, okay? So the first portion we need to use weird, I'm sorry. So it actually is weird. So here you get 1 3, so you got EI and then CRAGY. So this one is crazy sin. Okay, this one is a new crazy sin. The new crazy sin is like this, and then you get enigma. Okay, and you get 1 and 2. Okay, so that one you put in front of this, it should be NI. So it's NIERCRAG. So basically, number 15. Is C, okay. Number 15, wait. Crazy sin, okay, let me see. Okay, I'm sorry. Here actually, this one, it doesn't take in this, okay, it just get this portion, okay, the second portion here is get to R. It actually should get only the 4 letters, okay, so this one actually should be B, okay, this one actually, sorry, this is wrong. The second part, the second time it work on it, only get the EICR portion, okay, so this one is B, okay. So the first time you get EI and then CRAG, okay. Second time you got NI and get the 4 letter from here, so it's NIEICR. So get this one B, okay. This one has some trap. Number 16, you have passway N, okay, N pass in, which of the following data set test every possible pass through the code, okay. So here, this one is a test coverage. So you need to go through here goes through here, goes through here, goes through here. So let's look at the number part. Okay, so you basically you have first one less than -5. So -5 is over here. So -5. Okay, this region we have 1, answer 1. Okay, and then second part less than 0. So 0 is here. It lets you from here to here. Okay, this one is 2. Greater than 10, greater than 10, actually greater than 10. That actually is 3. Okay, and then else is number 4. Else should be this portion. That's number 4. Okay, so basically, if you want to check this whole thing, you should try these 4 zones. Each one of them should have 1. Okay, so -6 is actually zone 1. -1 actually is zone 2. 15 actually is zone 3. 12 is also zone 3. So A drop. Okay. Second one, actually you have -5 as zone 1. -3 actually zone 2. 8 actually is zone 4. 10 actually is still zone 4. So B also drop. Okay. I'm sorry, C drop. Okay, C drop. C also drop. Okay. So now actually, okay, I did not check the B. Okay, B. Okay, B I talked about it already. So B also drop. Okay. Now let's go to D. D actually -6 is zone 1. 0 actually is 0 actually, let me see. 0 is less than 0. 0 should belong zone 4. Okay, 0 should belong zone 4. 20 belong zone 3. Okay, 7 belong zone 4. So D also drop. Okay. So number 16 can only be E. Okay, let's check. Okay, so 10 actually is zone 1. -5 actually is zone 2. Actually, okay, this one zone 4. Remember, zone 4 should be solid dot. Okay, zone 4 is solid dot for both sides. Okay, the 0 belong to this side. Okay, -10 also belong to this side. 10 should be belong to zone 4. 12 is zone 3. So number 16, actually, answer is E. Okay, answer is E. Number 17, we have such a problem. Okay, here we have some problem. And 17 to 18 go by this. Okay, so there's a 70 degree, whatever. Okay, this different degree. But remember the problem here is that it used the if statement. So it will override the previous one. So 75, t greater than 75 will be dominated by t greater than 60. So it dominates this one. Okay. And then you have t greater than 45, it dominated this one. But t less than equal to 45, it is another way. So basically it only has the effect of the so-called t being tested on the 45 region. Okay, others don't take effect. Okay, others don't take effect because the problem of the logic design. Okay, so here consider the following: which range of the correct suggestion printed as above? Okay, which one can be printed as corrected as above? Okay, so 75, 60, no, less than 60, less than equal to 60, maybe not. So actually only 17 is actually, let me see, greater than 45, greater than 45, greater than 45, you actually including greater than 45, greater than 60, greater than 75, so it may not be correct. So only this one correct, because this one, less than equal 60 is correct. Why? Because less than equal 60, you have greater than 45 or less than equal 45. So both long will be correct. So the answer is D on 17. Okay. 17 is D. Because A is totally being overridden. Okay. B also overridden. C, you have partly been overridden. Okay. So the answer is D on 17. 18, okay, after the whatever, okay, here you multiply the things, okay. So what would happen? So here you have greater than 45, you go this. This one, again, it has a trouble because the first one you have a larger set greater than 45, you do something, and then greater than 60. So second one is dominated by the first one. So it should never be useful. So this one not useful, this one also not useful. Okay, it all being dominated by greater than 45. So the same effect will happen on this one. Okay, so here, what is the largest temperature range that actually the correct suggested answer will be printed. So the answer still get the same. This answer still be D. Okay, still be D. Still from 60 and lower, it is not being dominated, so it will be correct. So number 18 still be D. Okay, number 18 still be D. Any questions so far?
No questions.
No question. Okay, number 19, we have 1, 2, 3 problem. Okay, assuming the integer array have been correctly initiated sufficient size. Okay, which are what called is identical array. So identical means that they are the same. They are the same. So actually 1, 2, 3, they must be two the same or something. Okay, so let's try it. Okay, so I equal 0 and then I less than 6. I's half equals I. So let's try. Okay, so we have I equals 1. So it's 1, 2, 3, 4, 5. These are I. Okay, these are I's operation. And then our array should have what? Initially 0, 0, 0, 0, 0, 0. Okay, that's an initial value for the array. Okay, so I equals let me see. Here we have I equals 1. We go into there. I divided by, so A0 equals 1. Okay, A0 equals 1. And then I increase by 2. So it go to, so originally my I equals 1. Now I go to 3. I go to 3 and 3 less than 6. Yes. 3 divided by 2 actually is 1. So I1 will be updated. I1 equals I is 3 at this moment. And then I become 5. I check to 5. I check to 5. So I check to 5. I divided by 5, it becomes 2. So now we are going to operate on the 2. So 2 put a 5 in there. And then actually it increased by 2. So I becomes 7. I becomes 7 in start. So the A array is 1, 3, 5, 0, 0. Okay. Now second one we have I equal 0, I less than 3, and then actually AI equals, so it will go through I of 0, 1, 2, these 3 boxes. Okay. 0, 1, 2, 2 times 0 plus 1 is 1. 2 times 0 plus 1 is 1. 2 times 1 plus 1 is actually 3. 2 times 2 plus 1 is 5. And then I equals 3. I equals 3, you bypass. So this one, the second one is like this. Okay. Third one actually you have I equals 6. I greater than 0. So it's down counting. Okay. So it's starting from 6. 6 minus 6 is 0. So array of 0 equals 6. So array of 0 equals 6. So this one is different from all other people now. So seeing this, you can pick the answer is 1 and 2 the same. So A, okay. Seeing this, you don't need to trace anymore. Okay. That's that. This kind of problem actually very tedious and take a lot of time. Number 20, okay. Number 20, we have nation. The nation is Argentina, Canada, Australia, and then Cambodia, Russia, France. Okay, so here we have Argentina, Canada, Australia, Cambodia, Russia, and the France. Okay, that's the order of these. So here we are going to remove 0. Okay, so we are going to remove. So get I. Okay, so initially our I equals 0. So we look at this one. So if the length greater than 7, Argentina greater than 7, greater equals to 7. We remove 0. So we remove 0. When I equals 0, we remove Argentina. Okay. And after that, okay, Cambodia become, I'm sorry, Canada become 0 now. But I become 1. I become 1. Get I, we get Australia. Australia greater than 7. So we also can cancel this Canada. Then we become actually 0 go to the Australia. Okay, 0 go to the Australia. 0 go to the Australia, and we actually continue. Okay, so now we are going to, so this one is 0 and 1. Now we are going to 2. 2, we actually check. This time we check Russia. Russia is 6 later, so Russia actually will bypass. Do nothing. Okay, do nothing, and then this one is 2. So now we check 3. Okay, we check 3. Check 3. We check France. Check France. France FRANC is still pass. So basically, we should have these 4 left. Okay, so number 20 is C. We should have these 4 left. Okay, so this one must trace where you actually cancel and where is your index. Okay, remember that when the array list you cancel from beginning, the data's index will change. Okay, any questions so far?
No.
How about this? Are you okay
I think so.
so far? Whatever you have wrong, you are okay.
Yeah.
Yeah, okay. So we are halfway. So this round I spent 43 minutes. Okay. The real exam is 1.5 hours. So at this moment, we do use half of the time. Okay, because I'm talking and actually, so I'm not extremely fast. So something like this is about the right speed. Okay. So consider the following code segment integer array that is print the do start of the integer array. So this array being passed to here, and we are going to do something about it. Okay. So let's look at here. We do pass 33446 to here. Okay. So the array is actually 33446. Okay. Now index equals 0, maximum counter equals 0, equals 1, counter equals 1. So you go from I equals 1, I less than the length k increase. Okay. So if the 2 numbers are the same, it is starting from k equals 1. Okay. And then if actually the value equal the same, then you go into there and then see the counter. There's a counter and then there's a maximum counter. Okay. And k is a traversal index. Okay. So if counter less than maximum counter, then you update the counter. So I think this one called okay. So it's compared to the previous one. So your counter right now is actually 1. So going to here, you compare to previous number. Okay. If it is the same, then what? If it is the same, you go into here. If the counter greater than the maximum, greater equal to the maximum counter, then you will keep track of the index. So the index, you keep track of the current location. Okay, current location. And then maximum counter is the longest run number. Okay, longest run number. And if actually the number is same, your counter increase. Okay. Otherwise, if the 2 are not the same, you have a change on the data, your counter reset to 0. So here actually you will get the index. Eventually, the index you will get is the last element of the longest run. Okay, last element of the longest run. So you should return 4. You should return 4. So this one is not that hard. You need to try to understand it instead of tracing the whole algorithm. Okay. So maximum counter is to keep track of who is the longest run. Okay. Who is the longer run. index tell you which one is the last index of the longest run. Okay, so this one actually you got C that actually is 4. Okay, C that is the 4 is actually this 4 being selected. Okay, it's that 4 being selected. So this one number 21. It actually C. Okay, 4. Okay, number 22. Number 22 to 23 is a group problem. Okay, so here you do have a coordinate x, y. Okay, x, y, x, y, my, y. Okay, that's okay. Set x, set get y. Okay, set y, get y. Okay, this one is pretty easy. You actually don't need the code to make decision. So coordinate 0, 10. That's a point 1. Coordinate C3 pointing to the same point. Okay, let's look at this one. This one is an object operation. So C1 pointing to 0 and 10. C3 also pointing to the same location. C2 create 20 and 30. C2 that get Y that actually is 30. C3 that get set X. So here 30 being used to set this one. Okay. C2 assigned to C3, so C3 also pointing to C2. Then C2's the get X, okay. C2's the get X is 20. C3's the set Y, C2's set Y, actually this one set Y it become 20. C1's get X now is actually 30. C2's set X, so here becomes 30. Okay, so eventually you have a C1 pointing to 30, 10, C2, C3 pointing to 30, 20. Okay, so which of the following value will return 20? The value that will return 20 is C2 or C3's get Y. C2 or C3's value that will get Y is D. D will have C2 that get Y, so we choose. Okay, that's the value. 23, which the referring code returns 30. Okay, I'm sorry, I should not erase it. Okay, so that's it. Actually, let me recall it. Okay, I think the C2, C3 had the 30, 20. Okay, here I think it's a 30 and 10, something like that. Okay, so which one will return 30? I think the C1 get X, C2 get X, C3 get X. So actually all up. So this one 23 actually is D. Okay, I erased it, but I still have the impression. So the answer is D. Now 24. Okay, 24 we have the what to do. Okay, so they are testing the purpose of what to do. So you try to understand the purpose of what to do. So here you traverse through the half of the length. Sub 1 is the character I. Sub 2 is the character, the last character. Okay, last character of the string. Okay. So the current the character I and the last character. So very likely this one is a palindrome algorithm. Okay. So let's try. You will be palindrome. So the 24 is actually C. Okay. Checking the palindrome. Okay. This one pretty easy. You don't get confused by the data. It's just a get a total from the I and the symmetrical location of the I. Okay, number 25, you have this mix up. You have entry 1 and entry 2, and you kind of have these, so you would mess up. So here, be careful about the variable. Okay, so let's do this one. You have entry 1 that actually is AP. Okay, you have entry 2 that actually is CS. Okay, so entry 2 equals entry 1. So basically, entry 2 equals entry 1. So you both are pointing to AP. Okay. Entry 1 equals entry 1 plus entry 2. So actually, entry 1 pointing to AP. Okay. and then entry 1 is gone, no longer there, okay? Then entry 3 equals entry 1 plus entry 2, that actually is AP, okay, that's entry 3. Return entry 3, so you got multiple of the AP, that's C on 25, okay? Any questions so far?
No.
No? If you have any question, you can interrupt anytime, okay? So now we have this one called class person, adult, and the child, okay? So let's look at the class person. So person is a class. You do have adult that actually inherited it. You also have a child that inherited it, okay? Okay, so these are the different classes, okay? At this moment, just up to here, okay? So which are the following the correct implementation of child class constructor? Okay, so child class constructor. So here, let's see, we have child class. There's a local variable called AGE. There's a person. Person has a first name and last name. So the only thing you need to deal with is the first name, last name, and the age. Okay, so that's what we need to set up. So here you have first and last. Okay, super don't have age. So super you try to set age. That age is wrong. Okay, super don't have age. Child, and then you do super nothing. B actually is correct, okay, but you need to check, go back to check if the person has no argument constructor. Sorry, person does not have the no argument constructor. So B also wrong. B cannot have the no argument. C you have first, last, and then C seems to be okay. Keep it. D constructor don't need to have extend something. So 26, the only answer is C. Okay, D and E. Basically suicide because there's no constructor that need to extend anything. So they are wrong. Okay, they are wrong by that. First one is wrong. There's no super with age, so the person don't have age. Second one, there's no constructor with no argument in the person class. Okay, 27, which is the correct implementation of adult two-string method. So adult have a super first name, last name. Adult happen to have one more thing with title. So what he can do is first name should use the last name. So he only the get name and the title available to be used. Okay, he only have the get name and title to be used. So 27, okay. The two-string function is title and the super.toString. Super.toString. Super has two-string or not? Super don't have the two-string. Super don't have the two-string, so super's two-string will get the class the Haskell. Okay. So is that okay? That actually okay, but here we want it to be correct implementation. So we kind of hesitate to pick this one yet because this one is questionable. Compiler will pass, but if the data will work or not, we don't know. Okay, so the better way is you use get name is better. Okay, get name is better. Title is better. You don't see the variable last and first. Okay, and this one is print. Print is not okay. You two-string need to return a string, so this one is better. So now we only have B and E left. Okay. So we like to use get name instead of two strings. So 27 is E, okay? Because two string logically is okay, but the problem with the two string function is what? They will give you class name, so that will be person at the hash code number. Okay, so that is not what we want. So 20A, consider the following method declaration in the different class. We have find someone adult, okay, whatever. Assuming that the following variable have been correctly instantiated and initialized, okay. So PACRO, okay. So person adult, and here it actually processing adult. A function processor adult, you can only pass adult to it. Person no good, child no good. So you without compile, without error, only A can be there. And then child cannot be converted to adult. No, you cannot. Person cannot be converted to adult. No. So this one, 28 can only be 2 only. 28, let me see, it's actually A. Wait. The answer says C. Okay. C, you convert a person. Person is parent object converted to child reference, and you pass it to there. I don't think so. Okay, I don't think so. I don't think so. It's a proper value. It did not say that actually it's using a adult object. Okay. It did not say that. Actually, it's a 28 is questionable. Okay, 28 is questionable. A or C, I would say A better. Okay. A is better. C is questionable. Okay, C can only work if actually when you instantiate it, you use what? P equals new adult. Only under that condition, then your P can be passed to here. And then you use a conversion for it. Then that will work. Okay. So here it said that appropriate value. That actually is very, very weak. Okay. So this one, if number 4, okay or not, questionable. Okay. So I don't think that College-Board will give you this kind of problem. So this one, I would say A or C, both okay. Okay. Any question here?
No questions.
So basically, you can only pass a reference of adult type to it. Okay. So you have an object, you convert it to adult type. If it can be converted to adult type, that should be okay. But here you say appropriate value. Appropriate value is what? Do you use a new person or you use a new adult assigned to person? That is the question. This appropriate value is very weak. Okay. So this one, I personally would pick A, but the book answer says C. C is questionable. A, I think, is more appropriate. Okay. Number 29, consider the following method. The method is intended to return true if the value val raised to the power. Okay. So here value power, okay, target and the force tolerance level. Okay. So here, within the tolerance level, so the absolute value of the value and the target value, okay, the target value and the absolute value. So here, let's see, you are going to return the Boolean value. Okay, you're going to return the Boolean value. The Boolean value should be v raised to the power, okay, minus the target. Take absolute value need to be less than the tolerance level. Okay, so this one, the answer is this. Okay, less than equals the tolerance level. Okay, so this one is the answer is E29. Okay, it is v raised to the power p minus the target value less than equal tolerance level. Okay, 29 is by the definition of the math. 30, we have this. Okay, consider the following: change m, this. Okay, so we have a array. We have num1, num2. So this one, the typical pass using the value to evaluate the function. Okay, so we have change them. We pass 2 plus 2 and the 3, and the values actually is 1, 2, 3, 4, 5. Okay, we pass this whole thing into the array. Okay, so value of the 2, okay, assigned to num1, so num1 becomes 3. Okay, and num2 assigned to the values num3. Earlier num3 is this one, so we change it to this, okay? And then num2 increase become 4. And then return num2 become 4, so return 4. So this return 4, so num1 original is 2. And then here num2 actually original 3, so 3 change to 4. Okay, so at the end, num1 would be 2, num2 would be 4. The array become 1, 2, 3, 3, 5. Okay, so then num1 is 2, num1 is 2, so this one, let's see. Wait. Num2 actually is 4. Okay, num2 actually is 4. Let's try one more time. Okay, let's try one more time. This one actually may have bug. Okay, let's try again. So here we have the array is 1, 2, 3, 4, 5. Okay, this index 0, 1, 2, 3, 4. So we got this array, right? And num1 initial is 2, num2 actually is 3. We pass 2 and 3 to the array, okay, to it. And then, so we actually get the num2 values num2. Num2 is 3, so we get 4. 4 assigned to num1. So here this num1 become 4. Okay, so values number 4 we assign with value 4 we assign with num2. So this one we assign a num2. Num2 at this moment is actually 3 to there. Okay, so actually we multiply to the wrong set. And then num2 increase become 4. So 4 return back. So this one update to 4. So when we print it, it actually is 2 and then num4 equals 3. So the answer is C for problem 30. Okay. Okay, this one actually is tracing problem. Number 31, we do have this A to Z. Okay. So S1's index of the substring S2 the length minus 2. Okay. So on your side, first letter index, so S1 to A to G, okay, A to D, S2 the substring's length, okay, it's actually the length. So on your side of shape, okay, on your side you have 0, actually on your side, okay, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the length is 12, okay. The length is 12. So string 2 let's see, string, actually length 2, 12 minus 2. 12 minus 2, so it actually saying the last 2 letter. So this last 2 letter D is index of A's index of, so actually is 3, okay. So 31 actually is 3. C is the location of the DE, okay, location of the DE. Okay, 32, we have this problem. We have an array declare, and then we update array 2 and 3, okay. Other are null, I mean, it actually another class, okay, actually another class. Other are null in the beginning, okay. So missing condition, okay, missing condition, we actually go through every single one, and then we need to print it, okay. There's a certain thing you need to, number one, it must not be a null, and it actually is a array, so use get is not okay. Get is not okay. Get must not be okay. and then get data equals that 2. This one we don't know, okay? We are not terminate with the null exception. So actually, I think only this one, only A is okay. You have to check every element, not null. You try to get something, it will always be possible to be null, okay? Your null pointer, you cannot get something. And AC array by itself is not an array list. So get data is totally wrong. So basically C and D is impossible that array trying to get data. These are wrong. This one also wrong. Okay, only A is okay. So the last one, since not all entry contain another class, there's no way to loop through this. Okay, actually there are some way to loop through it. So you can only check these two. Okay, that's the only way you can check it. So 32 is actually, problem 32 is actually A. Okay. Problem 33, a programmer intended to apply binary search on this guy, but this one actually is wrong. Okay, this one is wrong. It is unsorted. Okay, unsorted is. The standard search will actually list. Okay, so what is returned by the algorithm when the search for 50 is actually executed? So let's see. Actually, let's actually do it one by one. Okay, it's actually let's see. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one's 10. This one's 0. In the beginning, we check 0, 1, 2, 3, 4, 5. So middle value is checking this one. We had a 50. We had a 50, and then actually 50 is bigger, smaller than that. So actually the high be moved to here. So high be moved to 4 on the first row. Okay, high being moved to low on the first row. So next one, we check 11 with 50. 11 is with 50, and 50 is bigger. 50 is bigger, so we move our low to be here. So actually 3 and 4. 3 and 4, this one we check 45. We check 45. 45 actually is smaller. We move our low to mid plus 1. We become 4 and 4. 4 and 4, we check 76. 76, it actually is smaller, so we move our high to be below 4. So high go down to 4, fall down to 3. So high at the end is 3, low at the end is 4, and we actually will return this value. Okay, so it will return -1 in this case. Okay, 33, you will return -1. Is that okay?
Yeah.
And you will not, okay, a quick way to decide it will be -1 is that the first one you compare 100, okay, you compare 100, and then you move your high to this side. At that moment, we know that the right side will not be searched. Only right side can have a right answer. So left side will never have the right answer. So this one, actually, you can directly pick one after you knowing that it's going to the left side. Okay. If you're going to the right side, you still have a chance to pick. Number 34, we have 2D array like this one. We do swap, okay, a ruler swap, okay, a ruler swap. So actually you have the X is the number, so A is a row number. So row number, for each row, you swap the first element and the last element every time. So this one actually, we should get a 210543 and A76. Okay, so 34 is C. This one is a direct pick problem. If you know about swapping, and this one is swapping every row. Okay, swapping every row. The first element, the last element. 35, we have a array list. Okay, and we have new array list. So we add the list of 0, we add 2 into there, And then we go through the array one by one. If the I actually greater than the last element, we are going to add it in. Okay, so let's try. Okay, so the first thing we actually get a 2, and we use a 4, and 4 bigger than 2, so we add it in. Okay, next one we actually get a 3. 3 greater than 4, no. 2, 3 greater than 4, no. 2 greater than 4, no. 5 greater than 4, yes. So 5 in. So you only pick the increasing data. Okay. So after the execution, when we print it, we should get A245. Only the increasing data. Okay. Only the increasing part of the data. So this is actually 5. 36 is a 5 by 5 array. 5 by 5 array, we actually do see this guy is somewhat a little bit like the upper triangle, but it is not. Upper triangle, you should have a -1 here, but it is not. Okay, so let's be careful. Okay, so the row starting from 0, so row is actually 0, 1, 2, 3, 4, right? Column is actually starting 1 plus row. So here 1 plus row is 0, 1. So the first one starting from 1, second one starting from 2, third one starting from 3, fourth one starting from 4, getting out of here. Okay. So here AC, okay, AC, you actually put every single one of them as 9999999. Okay. Then your D equals 0, D less than 8 the length. Okay. DD assigned with D value. This one apparently is assigning the so-called diagonal term. Okay. So then you will print 1, 2, 1, 2, 1, 2. Okay, 1, 2 is this one. 1, 2 is a 9. 1, 2 is a 9, and then 3, 3, 3, 3 is a 3. 4, 3, 4, 3 is a 0. So it should be 9, 3, 0. Actually, 36 is E. Okay, 36 E. Okay, this one is tracing the 2-dimensional array to put the data in there. Okay, 37. We have 4 more problems to go. Okay, we still have 16 minutes to go, so we have plenty of time. Okay, so and this one look like it is a what? Look like it's an insertion sort, right? It actually look like insertion sort. Look like insertion. That's also it's an insertion sort. Okay. Which of the one show the element after the second pass through the outer loop sorting? So 2 pass, okay, 2 pass is easy. That's also is an insertion sort. It looks like an insertion sort. So it's 91302. Okay. So let's get started. To be insert location is this one. Okay. So the first one actually ship and you put here. So it actually this one. Okay. Next one to be insert location is here. Okay. So this one actually 9 is bigger, so here and here. Okay. So it becomes this. So the answer is actually 13902 D37 is an insertion sort. Okay. So you must remember the sorting algorithm on this one. Okay. Must remember the sorting algorithm. You check it, it pretty much is insertion sort, so you don't need to trace it anymore. Puzzle M and T, okay, whatever, call puzzle 3, 4, okay? This one is typical tracing of recursive function. So puzzle of 3 and 4, actually 4 is not 1, so it would be calling 3 times puzzle of 3 and 3, okay, and you will be calling puzzle of 3 times 3 and 2, colon 3 times puzzle of 3 and 1. 3 and 1 will return m. M is 3. So 3 times 3, this one get 9. Times 3 get 27. Times 3 get 81. So this one is C. 38, problem 38 is C. Okay, and it actually is a function of m raised to n. Okay, this one actually is a m raised to n. Number 39, this is an array, the table of 3, 4. What is the value of 3, 4 after executing the code? So you need to go through the table. So table initially is a 5 row, 6 column, and then you need to fill some value to it. So there's an outer one. I think K is the column. It's a column major, and J is the table, the length minus 1. So it is column major, right? Column major, and it's actually backward going back. Okay, backward going back. And then it actually is column major, but row go small to large. Okay, large to small. Okay, so this one is actually trace it. So our table originally we have 0. We have actually 5 rows. So 0, 1, 2, 3, 4. Okay, and the value initially is 0. Okay, 0 we go to here. So this one we fill in a 0, and then here this one is row. Column is 0, 1, 2, 3, 4, 5. And he won table of 3 and 4. Okay, let's do it. So we have 2 fill in 0, and then we fill in 2. 2 it go up. So here 2, 4, 6, 8, and then 10, 12, 14, 16, 18. Okay, you see the pattern already. You see the pattern already. So this one should be 20. This one should be 30. Okay, and then here should be this one should be 40. Okay, so here it should be 32, 42. So you can pick this one here. It's row 3, column 4. It's D in this way. Okay, just like that. You see the pattern, we should use the pattern. Okay, any question on this one?
No.
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 How about Edison? Are you okay?
Yeah.
Number 40, the last question. Okay, here, okay, your selection sort. Selection tool, your I equals J equals I. You're trying to find the minimum value, okay, or maximum value. So here, here you should have minimum value. So here you have a string array, and you are going to swap the array. Okay, here you are going to do what? The array of string, okay, object, so that the selection sort, okay, is selection sort. Selection sort, you want to sort the array element by what? By the length of the string, or by the least to greatest. Least to greatest, but it's an array. An array, you need to use a compare. So a.j less than equal compared to the small one is actually greater than 0. No, it's less than 0. So number 40, getting the smaller number is E. You need to have a condition to find the current element smaller than the minimum. So number 40 is E. Okay, any question?
No.
No question, we finish it. Okay, so if you still have some problem, let me know. Okay, but we go over the way to do each problem today. Okay, and because some students get too many wrong, so I try my best to cover every single one. If you have fewer wrong, then I just go over those wrong problem. Okay, thank you. Good night.